How to plot a ground reaction force, Part 1, Checking Your Data, a series of biomech talk. So in this video, I'm going to show you how to check your data for creating a running ground reaction force plot. So I go through the process of finding an open source data set, then checking to see if that information is correct and makes sense in Excel using information from the literature. Okay, so I'm going to take you through the process that I used to find this data set. So I googled a bunch of keywords related to running biomechanics open source data set, and ultimately what helped me find this data set was searching the words running data set ground reaction force open source. And that took me to this GitHub page, and I scrolled through the information on this GitHub page looking for data sets that were going to be related to running. So I checked out this original data set and it was good, but it was using C3D files and I wanted to use a text file for this example. So then I went to this data set, which I found down below, and I was able to find some text files here. And so originally I didn't scroll down on this information, which would have told me pretty much everything I needed to know about the metadata for plotting this information. But that's okay, so I'll take you through the process that I used to figure it out without knowing this information and how I could have done it better for next time. Okay, now I was ready to take a look at the files in the data set. So this was a pretty large data set with a bunch of participants, and they had both kinematic and kinetic data. So that means there's going to be 3D motion capture marker data included in this set in addition to the force data. So these original files that I was scrolling through, those were marked as marker.txt files, which means that's the kinematic data, but I was looking for the kinetic data. So to speed this process up, I started to scroll towards the end of the files, and I was able to find where the force data was located. And you can see from the information on the labels of all these files, we've got RBD, S0, and then a number. So those are related to the different subjects in the data set. You see we found our force file, and then the T35 is going to be related to the pace. Alright, so my next order of business was to spend a little bit of time Googling because I didn't know how to bring this text file into Excel. Turns out you go to the Data tab and then you can hit from TXT or CSV. So then from there I was able to choose my file, which I had downloaded from the website with the data set. And then this gave me a preview of what the file was going to look like, so I could see the time, FX, FY, FC for the different forces, and the center of pressure information that's going to come from the force plates. And then once that was loaded in, I could see the different columns. It started me off with this green formatting, and I wanted to get a sense of what the data looked like, so I was going to plot the time versus the FZ axis, and I did this as a scatter plot. And I was a little surprised when this showed up because this data did not look anything like a force time curve, so not what I was expecting at all. So I started by adjusting my time scale on the x-axis to see if I could zoom in on the data to see anything a little bit clearer. So I zoomed into 800 and 1000, and once I did that, that started to look a little bit more reasonable, but still not like the vertical axis like I was expecting for a normal running force time curve. So I was a little bit surprised there. But as I thought about it more, I was like, oh, okay, maybe this is a different component of the force time curve. So let's try some more plotting to see what we find out. So the next step I took was to modify my data series. So with the dots, it was looking a little confusing. So I decided to switch it to a line instead. And I removed my markers. And this was starting to look a bit more reasonable, and I realized that this was likely the medial lateral component of the ground reaction force. So I decided to add what was happening in the FX and FY of the dataset. So I selected the time column and also the FX column using Control Shift down to highlight that whole column and plot that information. And then I also added the Y component of the data set by doing the same process. And as I scrolled back up, I could see that the graph was looking a lot more reasonable. So it looked like that FX component was likely the anterior-posterior component of the ground reaction force, and it looked like a typical braking and propulsion situation. And then once I added the FY, I scrolled back up and this plot was looking a lot more like a ground reaction force, which was very encouraging, so I decided I could continue with this data set. Next, I took a little bit of time to figure out some more information about this study. So there were 28 regular runners and their data was collected at 2.5, 3.5, and 4.5 meters per second using their standard shoes. Then I went down to the methods because this contains most of the information specifically related to the force data if we're trying to replicate graphs or plots that were created in a study. And so I found that this data was collected using a dual belt treadmill from a bird tech system, which is different than what we typically use in our lab. And then this figure did a nice job of showing the reference system, so the X, Y, and Z coordinates for their force data there. And then it also had some other information, so I found that the sampling rates for the kinematic and kinetic data, and so our kinetic data was sampled at 300 Hertz. And then it also had more information about the reference system, so it made sense. The Z-axis was the medial lateral direction like I thought, and then the X-axis had the anterior posterior, while the Y-axis was the vertical component of the ground reaction force. So now that I knew some more information about the study, I was ready to go back to my data and add a timescale. So I added a new column called time_seconds, and then I took the first column time and divided it by 300, which was our sampling rate at 300 Hertz. And this filled in my entire column with that formula, and then I was ready to adjust my time series, which was originally just samples of the data. So I had to go to select data and adjust the x-axis of all of my series that I had plotted so far. So instead of using the A column, I switched that information out for I and hit OK. And you can see that some of the data disappeared from my plot with that blue line. So that means that the data shortened because it's no longer in samples and now in seconds, which adjusted the x-axis of our plot. So I continued that for the other three different lines that I was plotting, and then I was ready to adjust my x-axis so I could see if the timescale made sense. So when I zoomed in from 0 to 10 seconds, I could see a bunch of different ground reaction force steps for that trial, and when I zoomed in from 4 to 5 seconds, I could see a couple steps up close, and looking at 4.2 to 4.4, about a 0.2 second contact time, that made sense for this ground reaction force. Now I'm going to talk through just a couple more things about this information. So we can see the gray line is our vertical component, orange is the horizontal component, and the blue is the medial lateral direction. And what's interesting about the blue line or the medial lateral is that if you look at each consecutive step, you can see it's positive at the end and then negative for that next step. So each step it alternates because our reference system remains the same. The positive medial lateral direction will switch for each foot. At this point, I'm feeling pretty good about my data, but just to verify a couple more things about the timescale, I went back to the paper and found that these were the paces recorded at. And after reading some more, I found that each athlete, they collected data for 30 seconds at each pace. So to double check this, I switched the timescale from 0 to 180 seconds, and you could see that the data was squished into the beginning. And then once I switched this to a maximum of 30, I could see all of the steps in one continuous series. So in this video, I found an open source data set for running ground reaction forces, verified that this data was valid and could be used for us to create a plot, and then next time in part 2, we'll go through how to create that ground reaction force plot in Python. A series of biomech talk, how to plot a ground reaction force. Part 1, checking your data.